Looking at example 1, section 4.5, we did logarithmic functions in the last section. I'm sorry, we did exponential functions in the last section. Now we're doing logarithmic functions. So as you can see up there, and hopefully you've read in the book about how you differentiate, how you take the derivatives of logarithmic functions. What we really need here, this is the formula that we need. There's one for the natural log, and then there's one for a logarithm of a different base. But really, the natural log one is just a special case. So if I've got log base a of some function, really, yeah, so in part A, all we need is this. Log base a of x is equal to 1 over the natural log of a times x. Okay, so that's what we're going to use here. Before we do this one, though, we got to remember that we have all these nice properties of logarithms. So I'm going to go ahead and just rewrite this function. Remember that if I have the logarithm of the product of two things, I can write that as the logarithm of, or actually the sum of two other logarithms. This is the product to sum property of logarithms. So that's where I'll want to start. I'll use those properties of logarithms to rewrite the function, and then I'll take the derivative. So that ln2 now is just a constant, so its derivative is 0, and now I just have left is ln x. Its derivative is simply 1 over x. And again, I say that this is a special case because what's the natural log of e? Remember that ln means log base e, so the ln of e is just 1, so this just reverts to 1 over x. So basically, the derivative of ln x is simply 1 over x. Okay, the next part, we have a logarithm with a different base, so we will actually have to be using that. So this is y is equal to log base 3 of 5x. And again, the first thing I would recommend doing here is to separate this. This is a product. We can use that nice property of logarithms that will separate this into a sum of two other logarithms. So we'll get this. And this works for any base logarithm. You can always split it up like that if you have a product. Okay, then if we want to take the derivative dy dx, again, that's now a constant, so its derivative is 0. Now I've got that, and this is where I'm going to use that formula up there. The base here is 3, so our derivative is simply 1 over the natural log of 3 multiplied by x. So that's it. That's our derivative.